In this video, we're going to show you how Green Wasp Removal trains and mentors the Manchester University Wasp Survey team to collect live wasp specimens from around the community so that they can be used for Venom Immunotherapy, which is allergy shots for people with severe or lethal venom allergies. The field operator you see here in a swarm of bald-faced hornets that are trying to kill him is Jaden. He's using a vacuum system that consists of basically a shop vac type vacuum with a collection bottle on the end of it in which we collect all of our live wasp specimens. And it has a filter in it so they cannot be sucked down the tube into the vacuum itself. They stay in the collection bottle. Once we've collected all the flying wasps that we can, we then collect the brood comb from the nest, which is where all the baby wasps are born. Inside that brood comb, you see eggs that have developed into small larvae. And once they become more mature larvae, like these you see in the red circle, they weave a silk cap, like this white cap, over their cell, and they use that as a cocoon-like structure to pupate. During pupation, they become adult wasps, and once they're adult wasps, they chew their way out of that silk cap. That's what you see this wasp doing. It's actively chewing away its silk cap. It will emerge as an adult wasp, and at that point it can be collected while it's in captivity so that we can use it for venom immunotherapy, as we will with the other wasps we have already collected from this nest. Here you see Jaden going through the process of freezing our adult wasp specimens in frozen CO2 to preserve their venom. There's two reasons we use frozen CO2 or dry ice. First reason is it knocks out the wasps instantly and humanely, and secondly, that flash freezing process is the best way to preserve wasp venom for biomedical use, or venom immunotherapy in this case. It's crucial to not allow venom collected in the field to degrade. The next step here, you see Jaden preparing a freezer bag with the name of the species and the date the species was collected. Now he's taking the frozen wasps out of the cooler once they've been frozen solid, and he will transfer the frozen wasp specimens into the freezer bag. It's very important that we do this quickly and efficiently so that they don't have a chance to thaw out. If they thaw out even for a few minutes, then the venom will be ruined. We then transfer the species bags into a chest freezer, and we store them until the end of the season when we ship all of our stock out to the biolabs that create venom immunotherapy products for patients. Here you see Jaden taking the brood comb and putting it into one of our incubation habitats. You see the larvae are alive and well. The pupating wasps that are underneath the silk caps you see are what we're going to be collecting as they become adults. Here you see what it looks like when the wasp has finished chewing away her silk cap, and now she's about to remove herself from the cell. It's very similar to when a baby chick is chewing its way out of an egg. This process helps them gain strength. The proteins in the silk itself give them a little bit of sustenance, and here she is finished, and she pulls herself out. This is how every species of eusocial wasps is born. They go through full metamorphosis from egg to larva. The larva changes through multiple instars, which are different phases of development, and then they pupate and come out as adults. Newly born wasps are not aggressive. They don't know how to sting yet. They don't know how to fly yet, so they're quite easy to handle at this stage. Pretty much all they know how to do at this point is follow their instinctual behaviors, the first of which is to seek out sustenance directly from the nest itself. You see her dip her head into the cell here. What's in that cell is a less developed larva that still has not woven its silk cap. And that larva is producing a fluid, which is a protein carbohydrate enzyme mixture that the adult wasps will drink throughout their lives on the nest. This exchange of fluids from two-way feeding mouth to mouth is called trophallaxis, a very important process on the nest. So the wasp will spend a couple of days doing that on the nest to gain strength. When she's ready, she'll become a worker wasp or a queen to be, or if the wasp that comes out of the cell is a male, it'll be a drone on the nest. Regardless, this is what the process is. From egg to larvae to pupae to adult, you can see all of those stages in this shot. Once the adults are strong enough, they begin to bring back food for the larva. So this two-way feeding continues, and in this case, they bring insect protein to the larva that eat exclusively protein. This evolutionary behavior they developed of two-way feeding, the larvae feed the adults and the adults feed the larvae, is a pretty brilliant evolutionary move as far as survivability. It's been said that the larvae are the engine of the nest. because they produce that life-giving fluid that the adults want to drink, so the adults have high incentive to feed those larvae as well as they can. The key is that mutual dependence. Here you see a few days later, we've added a couple of more combs, and now the pupating wasps have hatched out, and you see us collecting them here for venom immunotherapy. So most of our wasp removal jobs and our venom collections in the field actually have two parts to the process. First is to collect all the flying wasps, as you saw earlier in the video, right out in the field. Second is to incubate the rest of the brood. Now here you see Jaden and the rest of the WASP survey team on this date out at Izaak Walton League collecting more bald-faced hornets. Thankfully, your North Manchester chapter was aware that these wasps are actually beneficial insects and they can go to good causes in venom immunotherapy, so they called us rather than simply spraying the nest with toxic poison pesticide and killing it, wasting it. What we're trying to encourage everyone to do is to not only stop using pesticides and poisons in your own living space, your own yards, your own buildings, your own homes. There's better ways to do it that don't involve toxins. And then you can use these wasps that have not been poisoned for biomedical use, like venom immunotherapy, to save human lives. Another main focus of what we do is educate people about the beneficial nature of wasps in general and why they're important to every ecosystem they exist in around the world. We help people learn and understand that wasps are the apex predators in the insect world that help control the populations of many other insects. Adult wasps hunt pest insects, and they feed them to their larvae. That's how the larvae get protein that they need to develop into adult wasps. And if we did not have wasps actively hunting all these other pest insects around the world, insect populations would immediately explode globally, and we'd be in a biblical type pestilence that we could not recover from. We must have wasps, we must conserve them, and we are trying to educate people about this. It's well known in entomology, which is the study of insects, that however the insects go, the rest of the world will follow. So if our insects go extinct, then the plants and the animals that depend on these insects also go extinct, and then we go extinct. It's that simple. Here you see the nest we took off the building at Izaak Walton League, moved into an incubation habitat. All we need to provide it with is honey and water. And a few days later, as you can see, there's a lot of wasps ready to be collected. Adult wasps live on sweet carbohydrate fluids primarily. They only collect protein. They only hunt insects for their larvae. They feed all the protein to the larvae. So in our incubation habitats, we're primarily interested in allowing those white cap cells to pupate into adult wasps that we can collect for venom immunotherapy. Any of the younger generations in the nest, such as eggs or developing larvae that have not pupated yet, we don't typically save them in the incubation habitats because they're just too difficult to feed. Adult wasps, on the other hand, after they come out of pupation, are very adaptable, very hardy, easy to keep in captivity. Here we have returned to the Izaak Walton League for another nest they had to get removed. And for this job, you see Sam here is rigged up with our backpack device, which allows him to climb up into trees or on ladders, wherever he has to go, that requires extra mobility, and a battery system where we have no cords attached to him at all. Here you see Katie and the rest of the team stabilizing the ladder and providing support to Sam. And we had one of the team members go into the tree with a support pole. And then Sam climbed up the ladder, was able to use the vacuum device by balancing it across the support pole, and that allowed him to collect at this nest at height without any fatigue. Again, to the credit of Izaak Walton League, they were aware that this was the type of thing that could be done safely without having to kill the nest or poison the nest, and we really appreciate that about the Izaak Walton League. Our whole team feels very much aligned with your mission of conservation of the ecosystem and all of the living things in it. We very much appreciate working with folks who understand that. So the field techniques we've developed with our team make it feasible to collect wasp nests from literally anywhere we find them. Every member of the team is adaptable and sharp and willing to learn and willing to experiment and try what works. Their willingness to innovate and come up with ways to just get the job done is inspiring. It's really a pleasure to work with these folks, and they have done an excellent job all season long. Here we show you some footage of freezing the wasps we collected from the tree at Izaak Walton League. And this time when we decided to incubate the brood comb, we took the entire nest rather than just the brood comb. And rather than put it in a glass habitat in the barn lab, we brought it out into one of our free-range incubation habitats, which are simply animal cages suspended from trees, which allow the wasps to come and go at will, to forage normally and fly normally. The concept here is just to allow them to be as closely aligned with their natural habitat as possible while still being in captivity enough to allow us to collect them readily. Here we move on into another species. This is Katie out in the field collecting invasive German yellow jackets, or Vespula germanica. This is a Eurasian species. It comes from the Mediterranean countries in Europe and also northern Africa and a little bit of temperate Asia. This species, at least in North America, has become a real problem in structures. They love being in people's soffits. As you see here, they'll make massive nests inside people's buildings. And here they can do structural damage. They can be a sting risk for people. They can cause a mess inside your building or walls or attics or joist bays in your floors, any of that. This species makes some of the largest nests that we deal with as far as population inside the nest, so they're great for collection for venom immunotherapy. Another species we deal with a lot here in upstate Indiana is the native eastern yellow jacket, or Vespula maculifrons, and this is a very important wasp here. They help control lots of our pest insects, so they're very beneficial. However, they live in the ground, as you see here, thousands and thousands of them at a time in these nests, so they can be very dangerous to children outside playing, or pets being walked in the backyard, or just mowing your lawn or something. You stumble across one of these nests can be very dangerous. So what you see here is Coco from our team using a borescope camera to get a good visual on the nest underground so that we can get a good idea of where to dig to try to find the brood comb. Eventually we find where to dig and we pull the brood comb out. As you see here, she's working with her partner from the team named Milo. Together, they were able to get this nest removed. They did an excellent job. What we try to do is collect all the flying wasps first, to collect them for venom immunotherapy. And as always, we pull the brood comb out, and then we can bring that back to our barn lab, and hopefully if we can incubate enough of them, we can get several more collections out of that nest. So as you can see here, our team has become quite expert in working in trees, in buildings, working underground. Wherever the nest takes us, we're going to go. And the team has just done a fantastic job with adapting to all of these environments and learning as they go. And they seem to get a true kick out of it. They really enjoy it. We often interview them, like we're interviewing Coco here, about her experiences on these teams. And what she's explaining here is that she was fascinated by using the borescope camera, and she was amazed that so many different types of species live underground when you're used to seeing them maybe up in trees only. And she's really enjoying her experience. And we find that to be the case with everybody on this team. They all seem to get quite a lot out of it. At the end of the day, what we want for all of these students is to work as ambassadors for this entire concept of green wasp removal, where you simply do not need toxins to deal with wasps of any kind anywhere. You just don't need poisons to do this. We have better ways to do it now. And we want them to understand how to get out into the communities that they live in or that they go out into after they graduate, and explain to those communities how beneficial wasps are, and not only for the ecosystem, but also for human life. They can be used for venom immunotherapy to save people, and that is the way we should use them, rather than killing them with poison. Now, for the last couple minutes of this video, we're going to show you a little bit about what happens to our wasps after we collect them. Each year, collectors harvest thousands of pounds of wasps for venom immunotherapy. They are then transferred to the biomedical labs, who process them and create the product that is ultimately used to treat patients in these allergy clinics. The process is extremely labor intensive. The technicians in these labs, they have to pull out the venom sac, roughly the size of a pinhead, and it's removed from each insect with tweezers. They collect them into a vial. It can take up to 130,000 venom sacs to produce one single batch of the raw material that will be used for venom immunotherapy products. That's about 520 man-hours for a single batch of venom product. It's a pretty intensive process, and that's just the beginning of a months-long process from beginning to end to get these products to market. Once the process is finally complete after a few months, The venom product ends up in the hands of the doctors, who then give the venom immunotherapy information to their patients. And if the patients decide to go for the treatment, they can be cured for life from bee and wasp allergies simply by getting enough shots over a period of years. Most patients receive shots for a period of 3 to 5 years. After just their first couple of weeks of shots, most people develop some immunity right there to no longer have anaphylactic reactions. So this VIT treatment is up to 98% effective. It's an amazing success rate. So after their shot regimen ends in 3 to 5 years, they are immune to bee and wasp venom for life. Their allergy is essentially cured. They experience an amazing improvement in their quality of life, and we're very proud to take part in that process. We're especially happy to work with supportive and aware and informed community partners like Izaak Walton League. We work in tandem on a project that not only saves the ecosystem from becoming more and more toxic every year, but also saves human lives here in the States and around the world. Many of our North Manchester wasps could end up going from a tiny American town in the middle of the Midwest all the way to some of the largest cities in Europe, saving children, adults, grandparents, husbands, wives, brothers, sisters, you name it, whenever they get treatment that they need to improve their quality of life. We salute you, Izaak Walton League, for taking part in this journey with us.